Hello there, Mr. Sutton here, bringing you the Algebra 2 7-4 Part 2 homework solutions on adding and subtracting rational expressions. In this one, we focus on situations where we have unlike denominators. So we have to find some LCDs. For this problem, since I have unlike denominators, let me figure out the LCD for this. So let's start with the numbers, 5 and 6. The smallest thing that those both go into is 30. And then we also, in addition to the 30, we're going to need an x for those x's there. Just one x though, because it appears at most one time. So now, what does each of these need to become the LCD? Well, 30x divided by 5x is 6. So I have to multiply this first fraction by 6 over 6. That's my fancy form of 1, my foo-foo. And then for this next one, I need to multiply by 5 over 5 to get 30x in the denominator. So that's going to be 72 over 30x. Minus 35 over 30x. Subtracting my numerators, 72 minus 35 is going to be 37, and we'll still have that denominator of 30x. And these can't be reduced at all, so this one is done. On this problem, since I don't have the same denominator, let me see if I can find an LCD. So my LCD is going to need a 5 for this 5 here. And we also have an x, actually x squared. Since we have an x squared in one of these, we need the full x squared in our LCD. Now, what do I have to multiply each of these by individually to get that LCD? Well, 5x squared divided by 5x is just x. So first fraction, we'll do x over x. And for the next fraction, we'll just need to multiply by 5 over 5 to get the 5 piece of that. So that gives me 2x over 5x squared plus 20 over 5x squared. And then just combining those numerators, we have 2x plus 20 over 5x squared. Now I can factor the numerator a bit, but if I take out a 2, I'm going to have x plus 10, which isn't going to cancel anything, so I'm just going to leave this the way it is. For this problem, I see that I have different denominators, so let me go ahead and get the LCD for this thing. I'm going to have to include the x minus 3 here, and also the x plus 1. So this first fraction needs the x plus 1 over itself to give us that full LCD. For the second fraction, I just need to multiply by x minus 3 over x minus 3. So now, cleaning this up a little bit and distributing in that first fraction, we end up with 9x plus 9 up there, and the LCD downstairs. And for the next fraction, we have the LCD, and we have 2x squared minus 6x. Combining my numerators together, we're going to end up with a 2x squared, that's the largest term. 9x and a minus 6x gives us a plus 3x, and then we have a plus 9. Now I always need to check at this point to see if I can factor and reduce this. 2x squared plus 3x plus 9. I'm not sure if that's factorable or not, but if it is, I can use the AC method on it. So my AC value would be 2 times 9, or 18. So I'd be looking for things that multiply to 18 and add up to 3. Well, 1 and 18 doesn't work, neither does 2 and 9. 3 and 6 would work if they were opposite signs, but they have to be the same sign to get a positive 18 out of this. So there's actually nothing that ends up working, so this one is as done as it's going to be. For this problem, since I have different denominators, I'm going to get an LCD and try to turn everything into that. So before I do that though, let me factor my denominator over here on the right. Looks like I can take a 3x out of all that. So that leaves me with an x plus 1. So now that I can see all the factors, putting that LCD together is going to be a little bit easier. So for numbers, 9 and 3, the smallest thing those both go into is 9. Next up, we have an x squared. That also covers the x in this second fraction. And finally, I need an x plus 1 in there because that's not otherwise covered. So let's figure out what I have to multiply each of these by individually now. Well, I already have the 9x squared piece in that first fraction, so that just needs the x plus 1 over itself to be complete. And for this other fraction, I've got almost everything, but I have 3x instead of 9x squared. So I need to multiply this second one by 3x over 3x. All right, let's clean these up a little bit and distribute. So for my first fraction, I have 7x plus 7. And over here we have x times 3x, so 3x squared. Since I have the same denominator, I can just move all that together in one big fraction. So we have a 3x squared, a 7x, and a 7. Now, is this fully factored and reduced? Well, let me check. If I do the AC method, 3 times 7 gives me 21. So I'd be looking for things that multiply to 21 and add up to 7. Not a lot of options. 1 and 21 doesn't work. 3 and 7 doesn't work. So this one actually can't be factored any further, and I'm done with this. On this problem, I noticed that I have fairly different denominators here, so I'm going to need to get the least common denominator, the LCD. Before I do that, I think it would be helpful to factor these a little bit. So for my first fraction in the denominator, I can take a 2 out of that. That leaves me with x minus 1. For this next denominator, I'm looking for things that multiply to 3 and add up to negative 4. 1 and 3 will work if they're both negative, so x minus 1, which I see is a common piece here, and also x minus 3. So putting my LCD together, I need a 2 and an x minus 1. I've already got an x minus 1 for this piece, but I still need an x minus 3. Now I'm going to multiply each fraction by whatever it needs to complete this LCD in the denominator. For my first fraction, I still need the x minus 3 piece, so I'll do x minus 3 over x minus 3 for that first one. For the next one, I've got almost everything, but I still need a 2. So 2 over 2. Multiplying all this out now. For my first fraction here, I'm going to have x times x, which is x squared. X times negative 3 is negative 3x, but we also have a 2x in there, so that's negative 1x total. And then we have a negative 6. For this next one, I have a negative 4x, because negative 2x times 2, and also a negative 2. I'm going to move these fractions together now since I have the same denominator. When I do that, I'm going to distribute this negative to this second fraction. So I have the x squared minus x minus 6 from the first fraction, and distributing this negative, I now have a plus 4x and a plus 2. Adding all that together, I've got an x squared, negative x and 4x gives us 3x, and then we have a negative 6 and 2 gives us negative 4. Now it looks like I can factor my numerator a little bit more, things that multiply to negative 4 and add up to 3. 1 and 4 works if I have negative 1 and positive 4, so x minus 1 and x plus 4. And it looks like I can cancel out these x minus 1s. So my final answer, I'm going to have x plus 4 over 2 parentheses x minus 3, and since I canceled out these 1s, I have to have x not equal to 1 as part of that.